We're gonna do a little extra practice with some 45, 45, 90 triangles and 30, 60, 90 triangles. Our special right triangles in geometry. So I've got this 45, 45, 90 triangle here with a side of 6. I want to solve for my two missing sides. We'll call those x and y. Now I can set up what I like to call my super proportion, where my normal 45, 45, 90 triangle sides are 1, 1, and root 2. That's like my most basic of 45, 45, 90 triangles. As basic as they come. Okay, that's the 45, 45, 90 triangle that likes pumpkin spice lattes. So, across from our 1 is our 45-degree angle. And then we have that here as well. And across from the root 2 is our 90-degree angle. Okie doke. So it's all talking about what angle it's across from. So across from our 45 here is a 6. So I'm going to pop a 6 up here. Across from the other 45 is an x. And across from the 90 is our y. And now I can just cross multiply and solve. So if I go to solve this first one, I would cross multiply those, right? And I'd end up with 6 times 1 is 6. 1 times x is x. Boom, there's one of my solutions. X equals 6. I can do the same with the outer two. Let me write that down again. We got 6 over 1 equals y over root 2. I can cross multiply these two, and I'm going to get 6 root 2 equals 1y, or just y. And there's my solution. Awesome. Sometimes they get a little more tricky, though. We'll do that in the next problem. Alright, so let's say I've got x and y over here that I want to solve for, and I've got my hypotenuse this time. So when I set up my super proportion, I've got 1, 1, and root 2 for my denominators, because remember that's the most basic of 45, 45, 90 triangles. Now, for the 1s, that's across from our 45-degree angles, which would be my x and my y, but over my root 2, that's across from my 90. Across from my 90 is a 10. I put that up there. Boom. Alright, so if I want to solve for x and y, I'm going to need to cross multiply. Well, if I'm solving for x, it's going to be x times root 2, right? X times root 2 and 10 times 1. So I'll have x root 2 equals 10 times 1 is 10. How do I solve for x? Boom. Divide by root 2. So in our class, I'm cool with either decimals or, so I would plug into my calculator 10 divided by root 2, and I get an approximate answer. I don't have a calculator handy, so I'm gonna pause on that one for a few. But if I want to get an exact answer, I got x equals 10 over root 2. You may remember this from algebra. This would be like the proper math way of going about it. I would multiply by root 2 over root 2 to rationalize my denominator, so I get 10 root 2 over, what's square root of 2 times square root of 2? That's square root of 4, which is 2. And I got to simplify it a little further down to 5 root 2, because 10 divided by 2 equals 5, and boom, there's my exact answer. Awesome. And now that I have a calculator handy, let me do 10 divided by root 2, and that's going to give me 7.07, which would be, rounding that would be 7.1 approximately. Woo! So I'm okay with either 7.1 or 5 root 2. Either of those will work. In an algebra class, you'll need to have the exact answer, which is the 5 root 2. Alrighty, so now I got myself a 30, 60, 90 triangle. That's got a different super proportion, we'll call it. Or we got 3 of them. So it's 1 root 3 and 2, and that's across from the 30 for this guy, across from the 60 for this guy, and across from the 90. Biggest side's across from the 90. 2 is bigger than root 3. Think about it. Root 4 is 2, so root 3 is going to be smaller than that. Okay? So those are my sides across from those particular angles. Well, across from the 30-degree angle right now, I've got myself a 7, right? So that's going to go above that 1. So when I set up my super proportion, the 7 is going to go above that 1. Now let's say this guy's x and this guy's y. What's going to go across from the 60? The x, and across from the 90 is y. And now I can solve for my other two angles, or sorry, my other two sides. So if I cross multiply here to get my x, I'm going to have 7 root 3 equals x. Then if I'm going to solve for my y, let's do that in a different color, I'm going to have 7 over 1 equals y over 2. Cross multiply, I get 14 equals y. Boom, I've got both of them all good, America. But there are more difficult ones, and we'll get into that in a sec. Let's say I got this bad boy right here. If I set up my super proportion like we did before, across from my 30 is my 1, across from my 60 is my root 3, and then I got my 2. Well, across from 30 is x in this case, across from 60 is 8, and across from 90 is my y. Now when I cross multiply these, it becomes a bit of a pain in the butt, I'll be honest. I have x times root 3 equals 8, and how do I get rid of that root 3? I got to divide by root 3. Now in math class we cannot leave a radical in the denominator as we discussed earlier, so for my exact answer I'm going to need to rationalize that. So I've got 8 over root 3, I got to multiply by root 3 over root 3, and that's going to give me 8 square root 3 over 3. Boom, that's my exact answer. My approximate answer, if I were to do 8 divided by root 3 in a calculator, I will end up with about 4.618, so 4.6 would be my approximate answer here. Obviously decimals are going to be more applicable for us in our class, but in an algebra or algebra 2 class, you will be expected to have this answer right here, rather than the decimal answer. Alright, how about for the y? Let's try and fit that in here. Maybe I can make this a little bit smaller, give us a little more room. There we go. Alright, for my y, I'm going to have, let's see here, 8 over root 3 equals y over 2. So I'm going to have 16 times y root 3. 16 equals y root 3. And I got to do the same thing here. I'm going to divide by root 3. Excellent. I need to rationalize, right? So I'm going to bring that. Let's bring this up a little bit more. Give myself a little bit more room. When I rationalize this, 16 over root 3 over root 3. I'm going to have 16 root 3 over 3. That is my exact answer. In the calculator, you can plug it in, 16 divided by root 3, and get a decimal. You may notice that 16 root 3 over 3 is double that of 8 root 3 over 3, which is what we got for our x. The one across from the 30 and my hypotenuse, they are double or half each other, whichever way you want to look at it. That is a commonality you will see with 30, 60, 90 triangles. All right, one more. Let's say I got this 30, 60, 90 triangle here. Notice it is in a different orientation, but I just need to pay attention to what sides are across from what angles. So my 1, root 3, and 2 stay the same. What's across from my 30-degree angle? That goes above the 1. What's across from my 60? That goes above the root 3. And what goes across from what's across from the 90? That's a 20. That goes above my 2. America. Time to cross multiply. So let's do our x first. That would be 2 times x equals 20 times 1. So 2x equals 20. X equals 10. Awesome. So boom, 10 right there. You may notice, again, it's half of 20. That is going to happen with 30, 60, 90s. And lastly, let's work on the y. So we got y times 2 and 20 times root 3. So we got 2y equals 20 root 3. Divide by 2. I end up with y equals, well, what's 20 divided by 2? That is 10 root 3. Woo-hoo-hoo! Wonderful. Excellent. That was so much fun. I know I enjoyed it. Delightful. Freedom.